Hi, I'm Michael Barton, Director of ComSysNet, and I'd like to talk to you about an exciting new initiative that ComSys is helping coordinate. A few centuries ago, people lived in small communities. Any individual could observe relevant social and natural phenomena and figure out the consequences of their actions on fellow humans in the natural world. This is no longer the case. Where we are today is that digital media, rapid transportation, these connect nearly 8 billion people economically, socially, and culturally in a planetary network of just lots of cross-cutting ties. And this is a highly complex social natural system, and it's one in which our actions, our decisions are critical for Earth system processes. This is unprecedented for any organism in Earth's history. So in this world we live in today, that's dominated by these rapidly changing processes, human and biophysical, that are telecoupled together, we can't depend anymore on human intuition and simple statistics to plan the future. We no longer live in the world of thousands of centuries to 1,000 years ago. So we need next generation data-driven science, modeling, to help us manage in a sustainable way the dynamics of a planetary socio-ecological technical system, the one in which we live in today. So grand challenge for our time is to try and figure out how we're going to grow scientific modeling infrastructure, right, to understand these interactions between people and the biophysical, the natural components of Earth systems. This is the topic of discussion at a series of workshops and strategic planning meetings over the last several years that are organized by a number of different scientific networks, including ComSysNet, and representing modelers of societal, ecological, geophysical systems. Some of the leading groups included AIMS, ComSysNet, and CSTMS. So kind of really spanning social and natural systems. And so the questions we wanted to talk about were, how do we try to integrate modeling of human systems and biophysical systems and their processes into kind of an integrated understanding of the interactions? How can we do this flexibly across scales? Because some of the questions we have are local, some are global. So how can we model across all these scales? How can we incorporate different conceptual approaches to modeling these human Earth system dynamics, not just global north, first world approaches? The world is a very diverse place with many important ideas, but how do we incorporate this into a modeling of next generation Earth systems? Importantly, how can we develop an environment that can help us answer questions through modeling that we can't even imagine? How do we develop scientific resilience? And kind of related to this idea of incorporating diverse conceptual approaches, how can we democratize advanced modeling technology to make it widely accessible to the global community where it's needed? Making these decisions to managing a planet sustainably is not just a question for a few highly funded institutes in the first world. This is a global issue, and so we need to make the tools to help do this better available globally. Beyond this is, how do we create some kind of an international scientific agenda to carry this out for integrative modeling of human Earth systems, building new capacity and data science and modeling at these multiple scales, and not discarding but building from current technology, current models, but still not be hindered by the legacy of these systems, and try to explore new directions. So what it came to was that we need to somehow build an environment that can support an ecosystem, potentially interoperable models created by different individual scientists and teams in different places in the world, not just by a few institutions. Enable representation of human systems, biophysical systems at local, regional, global scales to answer all kinds of different questions. This really kind of parallels the kind of world that we're trying to represent, this world of many different kinds of components, of social, ecological, geophysical, biological components that are interacting in many ways at multiple levels. It gives us, of course, flexibility, scalability to apply new ideas, new kinds of models in this kind of an evolving system. Now, this idea of integrative modeling is not a new idea, and it's widely known. People have thought about this and said this is the direction we ought to go, but it's been difficult to operationalize. Fortunately, there's been a number of technologies that have become mature recently that can help advance this goal. So one of the things that is really important in terms of is the ability to have platform independent reusable modeling through encapsulation. So that you can create a model and make it reusable across multiple platforms and make it future proof against changes in dependencies and platforms. There's been work, especially with colleagues at other institutions, on coming up with kind of an API wrapper with a shared ontology that you could put around these containers to make it easier for people to use the models and potentially even to link them together. Clever people could link them together to answer new kinds of questions. Beyond this, you can also add web services wrappers to make models accessible and runnable in a cloud environment, so you don't even depend on particular desktop operating systems. And hopefully one could do this not without throwing away things of the past, enabling existing models to conform to these kind of standards with minimal changes. This technology is going to be really helpful, but it's not sufficient. This kind of an evolving modeling ecosystem needs scientific practice, institutions to actually develop software standards for best practices and comply them. It needs to be able to disseminate information about standards globally to diverse stakeholders. Somehow administer the standards to recognize people who take the time and trouble to actually try to apply and utilize standards to make their code more accessible and more usable to more people. And at the same time, provide some kind of training or assistance and even incentives to modeling scientists to enable them to take on and use these new technologies and give some incentives to do so. So this requires some kind of a coordination at an international scale across the social and natural sciences. This is a social challenge as much as a technological one. A little over a year ago, there was an informal meeting to discuss some of the action items that have come out of these workshops and all this kind of vision of a modeling future, attended by representatives of a bunch of different scientific networks, including ComSysNet, but representing social, ecological, environmental, and geophysical sciences. Even more organizations have joined this initiative in the past year. And the idea was to come up with a federated meta-organization, a network of networks to develop, disseminate, and administer community standards in several different areas for access to model code, for consistent and sufficient documentation, for application of technologies and APIs to make code more reusable and interoperable. And the long-term goal is to support this self-organized modeling, evolving modeling ecosystem. So here's an example of the things we think we want to do is that we kind of, for accessibility, a standard. For example, people should publish their code in discoverable, open access, persistent, fair aligned data repositories. Model code should be documented so they can be understood and reproduced. Model code, to meet a reusability standard, needs some kind of encapsulation or similar technologies to make it platform independent and future proof. And interoperability require application of some kind of standard API and ontology wrappers for model integration. To carry this out, we envision a self-governing meta-organization, like I said, a network of networks. Maybe have working groups to focus on standards, education or training, developing proof of concept cyber infrastructure or assistant enabling cyber infrastructure. And some way to develop and administer recognized standards from a community level. How do we develop these, adopt these, and then administer them? We envision something like having a body that could review and certify code with digital badges that meet standards, provide professional incentives so that so people who go to the trouble of doing this actually get rewards in their professional life, and also support through doing this through training and cyber infrastructure. So where we are now with this is in kind of working slowly toward this vision. There was an initial planning workshop this past May in Germany to talk about a organizational charter. We've drafted at least an initial one. Want to try and get informal input from modeling science organizations on this charter. How would we organize this kind of a meta organization? There's been an agreement among at least 14 scientific organizations to at least agree to start planning the Open Modeling Foundation. This represents over 10,000 modeling scientists We now have a web framework and domain. You can go visit it, openmodelingfoundation.org. We've put in funding proposals. We've received funding from the Alfred P. Sloan Foundation for planning workshops in cyber infrastructure. We're planning additional funding to kind of get this off the ground. We've also already designed an open code badge, which has been adopted by 2 journals, working on more. This will identify journal authors who've made their code available in a trusted, searchable, discoverable, fair-aligned repository. And we've also now just started circulating an open letter calling for community modeling standards. You can go and take a look at the letter. If you agree with the ideas, please sign it and let other people know about it. So anyway, this is what we don't want to have happen, want to avoid this. And so I'll wind up by saying this is a large-scale community effort that includes many groups, organizations that can now go beyond those that are listed on this slide here. So thank you very much. Please feel free to contact me or ComSysNet if you have any questions about the Open Modeling Foundation.